So after question number 10, let us continue. That is question number 11. This question is based on the deriving the relation or deriving the expression using dimensional analysis. That is one of the application of dimensional analysis. So let us study about that. So question number 11. So question number 11 says that the dimensional formula for product of two physical quantities P and Q is, that means two physical quantities are there. When they are multiplied, that means product of two physical quantities P and Q is, that means when P and Q multiplied, the dimensional formula at the end of the answer is ml square T minus 2. Like this it comes as them given in the question. The dimensional formula of P by Q, dimensional formula of P by Q is, okay, how much is that? They have mentioned mt minus 2, like this. So only this much they have given. So now what they are asking, then P and Q are respectively are. That means when you arrive at what is the dimensional formula for P as well as separately for Q, then you will come to know they represent some actual physical quantities. So let us find out how to understand that. Now what I do is, let me take, we don't know what is the dimension formula of P. So for that sake what I do, I will just take m power capital A, L power capital B, capital C. Whether we know Q, we don't know. We are supposed to find out. Here also I will write m power A, L power small b, T power small c. So this is what the assumption. This is how we actually derive also. You might be remembering in first PU we have done derivations like derive the time period of oscillation of simple pendulum using the dimension analysis and kinetic energy. So many other examples you have taken. So here like this I have made. Now what I do, I will go for the multiplication of this first one. What is that? P and Q. When you multiply that P and Q, yes, left side of the equation I will write down the actual dimension formula which is given in the question. So first one, what is that? Yeah, the left hand side of the equation, m L power 2 minus 2. Left side of the equation, okay. So right side P into Q, that means you are supposed to multiply. So what is that? A plus small a, correct? Next L power B. Next C plus C. So this is we got when you multiply P and Q. First one I am solving here. So let us compare the powers here. So we can assume that this is A plus A is equal to a kind of lengthy kind of substitutions, but very very helpful in solving such kind of questions. So A plus A, yes, I can write m power 1, yes, that means 1 B, that means B plus B is equal to 2. What about C? C plus C is equal to minus 2, correct? This is what one set of equation I got to know now. Any substitutions is possible here? No, not possible. So I will continue. So because one more operation is also remaining here. What is that arithmetic operation which is remaining here in the given data? That is P by Q. So P by Q means, yes, you can see here. So I will write down. I'll write down in detail. Okay. Minus 2. This is division. P by Q, that means it will be in the denominator. So when you take the numerator, you know, A minus A it becomes. So like this, A minus A, B minus B, C minus C. Next, let us compare. Comparing both sides, we get A minus A is equal to 1. B minus B is equal to 0, C minus C is equal to minus 2. Here one set of equation I got, here one set of equation I got. So you can number the equation also, not possible. Okay, it's fine. So now let us evaluate these two set. Okay, I will take a plus a as well as a minus a here. I'll just add up those two equations. Finally we arrive at what? 2a. Therefore 2a is equal to 2. So a is equal to 1 I get. So here we got the a is equal to 1. Similarly, what I do is I will just continue with this. So let us equate this particular equation b plus b as well as b minus b, this equation. So here what I get is, so 2b is equal to, next this side, this will be, so b is also equal to 1. Similarly, let us go for the third equations here. C plus c is equal to minus 2 as well as here, and this is c minus c is equal to minus 2, and here what we get is, yes, let us check, that is 2c is equal to minus 4, or c is equal to minus 2. So now what I do, I'll just write down the values of capital A, B and C for the value of P. Just writing down the dimensional formula of this. So dimensional formula of this, what is that? So P is equal to m power A. So what is the value of A we got? That is 1. And next, L power B. What is the capital B here? This is also 1. And what about the power to be raised? Yes, what is that? Minus 2. So C minus 2. So I will write down minus 2. So now you can see here. So physical quantity P is equivalent to mLT minus 2. That means it is force. So this is actually equivalent to the dimensional formula of force. So that is what we can understand from this. Now whether it is finished? No, it is not, because we are having one more, that is to find out what is Q. So Q, let us discuss. So Q means small a, small b, small c. So let me evaluate now. Let us take values of capital A, capital B, capital C, and let us equate that on any one of the equations, either this or that one. So we came to know that. So here A is equal to 1, put the A equal to 1 there. So we can say small a becomes equal to 0. Then what about next? B value is 1. Substituting over here, so this becomes what? B equal to, small b equal to 1. What about small c? C. So c value is minus 2 here. Substituting here minus 2, so this comes 0 here. So small c is equal to 0. So when you write the dimension formula for Q, the equation will be m power 0, L power 1, T power 0. This is nothing but equivalent to what? This is nothing but equivalent to something regarding length. So what is that? Here it is not length, here they have given something regarding displacement. That means, yes, unit of length. So displacement. So what and all it represents? Force as well as displacement. So option is option 3. So hope it is clear for you people. So go through once again, because it is arriving at the equation. That means application of dimensional analysis. Let us go for the next question. So 11th question is over. The next question is question number 12. And the question is, the unit of length is doubled and that of mass. Unit of length is doubled and that of mass and time is halved. Unit of energy will be. So what they have given? Length is doubled and mass and time is reduced to half. Unit of energy will be. Let me just write the dimension of energy. That means ml square T minus 2, like this, correct? This is the dimension formula of energy. What they are saying is, length is doubled, mass and time has reduced to half. So let me just write this energy in terms of normally like this, okay? So ml square divided by T square, same form. This is an equation, okay? How we can represent energy. Now what I do, I'll take energy. That means once you do all those doubling and making half and all, I'll just for representation purpose, we are not supposed to write in small letters in dimension analysis. Here just for the substitution purpose I am using small m. Okay, so I will write m l square t square, where small m means mass is halved, it means made half, length is doubled 2l, and time, new time, that is 2 times t. Okay, now let us substitute here. So E dash is nothing but equivalent to m. M means m by 2. Next L means 2l square of that. Okay, divided by t by 2, it's a square. So while evaluating, what you get is 8 times ml square divided by t square, you get. E dash means, okay, what is ml square by t square? E. So how we can write now? So E dash is nothing but equivalent to 8 times E. So you can check in the options. So what is the suitable options for the current question? That means option number 3, 8 times. So that is all about the question number 12. So we have just altered the fundamental quantities here, and we arrived at the one of the answer. So take down. Okay, next let us go for the next question, and that is fundamental physical quantities that have same dimensions in the dimensional formulas of torque and angular momentum. They have given torque and angular momentum. Okay, we have to find out in torque and momentum, that means angular momentum, which are the fundamental quantities, because a physical quantity or derived physical quantity should be made up of fundamental quantities, right? We have to first search which are the fundamental quantities which are one and the same in both torque as well as angular momentum. So let me write first. So question number 13, torque tau is equal to, so it's product of, yes, of course, force into displacement, or yes, radius in which the rotation has taken place. I will directly write on the torque equation, ml square t minus 2. Next, angular momentum, L. So what is this here? ml square t minus 1. I have directly written the dimension formula. You can just write down the substitutions and you can find out if you have any doubt. Means both dimension formulas I have written in 13 question, and let us compare this. So mass, it is raised to power 1, here also raised to power 1. That means mass in the both equations one and the same. What about L? Yes, same. What about time? Oh no, this fundamental quantity doesn't have the same order. That means only mass and length have their equivalent similarity. That means they have the same kind of power to be raised. So we can say answer is mass and length is the correct answer. So that is all about question number 13. Let me go for the further question, that is question number 14. So let me read the question. The physical quantity which has the dimensional formula as of, they have given 14th question. Right now we are supposed to find out what is the physical quantity has the same dimensional formula as that of one equation they have given. What is that? Energy divided by mass into length. Energy directly I will write down ml square t minus 2 divided by mass m, let me write the square bracket as well, and here length capital L. Okay, try doing this. So ultimately what we get is LT minus, so this is what the equation at the end we are going to arrive. So LT minus 2 means you are familiar with this. This is the equivalent to dimension formula of the physical quantity acceleration. So answer is option number 4. Okay, that is all about the 14th question. Next, question number 15. Question number 15 says, look at the question. So if the fundamental units of length, mass and time are doubled, fundamental units of length, mass, time are doubled, the unit of force will be, unit of force, you know, Newton, And let us go for the dimension formula of that. What is that? Force F is equal to mlt minus 2. Writing individually, you can write like this. Now we are going to double everything. That means new force F dash is equal to, I will write down in like previous, okay? Small l, small m, small l divided by t square, where small m means doubled, okay? Like in the previous case, length, everything is doubled. T 2 times t. Done? Like this. Now what I do, I'll substitute that in the equation here, okay? So I will do it here. Hope it is visible for you people. M, everything is made double. F dash equal to 2m 2l divided by 2t square. 4. So finally what remains? F dash equal to, everything cancels, ml by t square, which is same as that of previous one. So what we can say from this? There is no change. No change. So what is the answer? Remains same. So option is 3. So 15th question is solved. So direct one step, you can finish it. So detail I have given you here, you can check. So that is about 15th question. Let us go for the next question, that is 16th question. So 16th question is something regarding, it consists, is one of the topic, important topic, Bernoulli's theorem, you might be familiar. Using the Bernoulli's theorem concept, we will apply that one in case of dimension analysis, okay? So it is question number 16. They have given, according to Bernoulli's theorem, okay? So in the question it is given like this: small p divided by small d plus v square by 2 plus gh is equal to constant. Like this they have given, okay? Then dimension formula of constant is, this constant is there, right? Its dimensional formula I have to find out is equal to how much? Look at this carefully. You know that checking the correctness of the equation means what? Irrespective of the arithmetic operation, whatever is there, they have to contain the same what? Same dimensions, correct? So suppose I evaluate only this one, I have to get the dimension formula of the constant. If I do this one, fine. This one also I have to get the answer. So what I do, I'll just choose this one, pressure. So they have given in the given data what is P, D, everything is density, pressure is the velocity, as well as this G acceleration due to gravity, and H is the height. So now P means what? Pressure. Pressure means force divided by area. Force mlt minus 2 divided by area L square. So what is the dimension formula? This becomes ml minus 1t minus 2, correct? Next, what is D? Density. Density equal to mass by volume. That means m volume, L cube, sorry, ml, like this, correct? So next, substituting, that is P by D is equal to, what do we get? That is ml minus 1t minus 2 divided by ml minus 3 mm. So this becomes L square t minus 2, like this. So which is the option there? Option is third option, where it signifies like this, m0. So this is the answer. Hope it is clear for you people. Substitutions, we have just taken what? Only one ratio we have taken. Why? Because each equation here, irrespective of their arithmetic operation, dimension formula of each of this one should be one and the same. So whatever the dimension formula constant contains, that should be same as that of either for this, either for this, either for this. So that is all about question number 16. So now let us move on to the next question. The next question is 17th one. So 17th question, let us see what it says. 17th question says something regarding change of, yes, application of dimension analysis, one of the change of unit from one system of unit to another system. No, it's kind of related to that one. 17th question says surface tension of a liquid in CGS is 45 dyne. That means CGS system they have given surface tension of a liquid. Okay, surface tension of liquid they have given. How much is the value in CGS system? It is given. Okay, 45 dyne per centimeter. The value in SI system is, in SI system, how much is the value? That is how we can convert. So now what I do is per centimeter. Okay, understanding, right? So here conversion requires what? Requires what and all? Yes, first there should be conversion from that means CGS system to SI system, correct? So because here what we have done here, actually we are using the concept of checking the correctness, almost correct. And before that we have done the derivation of equations by using what? By using the dimension analysis. So this is actually one of the applications. 17th question is one of the application itself. In that applications, what we do? We are going to just check how to convert that from CGS system to SI system. So let us go for that. So next what I write is, understanding this one, I'll write 1 dyne equal to 10 to the power minus 5 Newton, correct? 1 Newton equal to what? 10 power 5 dyne. What is 1 centimeter? 10 to the power minus 2 meter. So given that means we already know about this, correct? So this is what we can write. Now what I do is, by looking at the surface tension value of liquid in CGS system, 45 dyne per centimeter it is written, correct? Now what I do, dyne centimeter, I will convert that one into SI system directly. So what I do, I will just write down dyne per centimeter. So 1 dyne means how much Newton? I am converting, okay? So 10 power minus 5 Newton. Centimeter means 10 power minus 3 meter. That means how much? 10 power minus 2 Newton per meter. And we got, correct? Just 1 dyne per centimeter. So right now how many dynes we are having? 45 dynes. So this is 45 into 10 power minus 2 Newton per meter. That is what we can get from this. So 45 means how much? So we have to shift to decimal place. So this will be somewhere around 10 power minus 3 we got already, yes, correct. So 10 power minus 2, sorry, here 10 power minus 2 meter, sorry for that, okay. That means minus 3 Newton per meter, correct, 10 centimeter, okay. Make a change here. So 1 centimeter means 10 power minus 2 meter, 10 power minus 2 meter, correct. And now 10 power minus 3 here, 10 power minus 3. That means how we can write this? 10 power minus 3, 1, 2, 3. So we can write 0.045 Newton per meter. 0.045 Newton per meter is the answer. So whether the option is given there, yes, option is there, 0.045 Newton per meter, option number 2, correct? Yes, that is all about the 17th one. Here what we have done is change of system of unit from one system to another system we have done. From which system we have done? We have done that from a CGS system to SI system. So we should be very careful while converting. We should be knowing the values of that. That means 1 dyne means how many Newton, 1 erg means how many joules. Some of the standard values are there. You can just remember that, okay? Standard values, they are constant. Fine, let us move to the further question. Further question is, the unit of length and force are increased by 4 times. So next question is, the unit of length and force, okay? Unit of length and force, okay? It's not just another fundamental quantity. Length and one more derived quantity they have given. Length and force are increased by 4 times. The unit of energy will be increased by, they have given. Now, energy means what? Yes, many formulas are there for energy. I'll take one basic formula like this. Energy related to force and length. How I can write? I will write F into L, whether it is true. You can see here, force and length. Force into length. Something like torque. Torque means MLT minus ML square T minus 2. Torque and energy will consist the same kind of dimension formula. So I can use it for this one. So now, what I have mentioned, the unit of length and force are increased by 4 times it is mentioned. So, F dash 4 times, 4F. L dash 4 times. What else they are asking there? They are asking the energy will be increased by. So what I do, I will just multiply like this, okay? So, E dash equal to F dash into L dash. But increase in energy they have given. That means in percentage we have to mention, correct? So this is what, and this is just equation I have written in percentage, because in the question it is mentioned how much increase, correct? So what is that? So this will be E dash minus E divided by E into 100. What is E dash? New. That means new force. How much is that? 16 into F into L minus F into L divided by F into L into 100. So how much is the answer? Yes, you will be getting around 15 into 100. So 1500%. So this is the answer. So hope you can understand this. It is clearly mentioned. Energy in terms of force and length is mentioned. And in terms of force and length, they have given force also made 4 times, length also made 4 times. Here we have done, yes, separately we have taken just the next formula we have written, then substitution we have done. As we are supposed to represent this one in percentage of how much increase. Okay, what they have asked, that is all about increased by they have asked. So how much increase? So that is why final divided by initial energy. So final means E dash minus E, like that taken. 1500% is the answer. And what is which is the option there? It's option number 3. Next, let us go for question number 19. Question number 19. Let us see. Equation which is dimensionally correct is the question. Okay, so that means it is also one of the application of dimensional analysis. Am I right? So you might be remembering, check the correctness of the equation. S equal to T plus half a square. So many other kind of, okay, everywhere the dimension should be one and the same in individual terms which is mentioned in the equation. So let me go for question number 19, and question number 19 says the equation which is dimensionally correct among these following. You can see first one V is equal to U plus AT square. Check the dimension properly, it won't be true, but I will go for directly answer, that is S equal to UT plus AT square. Why I go for this one? Because in dimension analysis the constant doesn't have any importance, correct? That means if half is removed means it's not a big deal, because yes, UT plus half AT square. So this equation should be dimensionally correct. So what is yes? Length, correct? UT, that means LT minus 1 again T, that also have to give L. What about AT square? LT minus 2 again T square. So this also should be given with the same value. So all the terms contained in the equation have possesses the same dimension, so that we can say that this is dimensionally correct. So that is about question number 19. So let me continue for the next one, that is question number 20th. And the question is, if L, some value is given, okay, L and B, then L plus B equals to, so it's all about adding, okay, and along with that error value is also mentioned. So they have given the one of the value L, okay, is equal to 2.06 centimeter plus or minus 0.02 centimeter. Next they have given values for B, that is also one of the physical quantity, that is 1.11 centimeter plus or minus 0.03 centimeter. Now what we are supposed to do? L plus B is equal to how much? is to be found out. It is not just simply adding up, because we are contained with what is that? Error also. We have to go for the formula which is should be maintained or followed while evaluating. So first I will just calculate what is L plus B. How much is that? It is actually 3.17 centimeter. Without, by neglecting the error, suppose you add means this much you will get. Now what we require? We require the error, that means delta, correct? So how much is that? Let us see. So I will take L plus B is equal to how much, right? So I will take this one as x equal to L plus B. Now I have to find out what? Delta x by x, error in that. That means delta L by L plus delta B by B. It's just unknown x, okay, whatever the parameters. Next step is add this. So taking the denominator as well as numerator, I will write down here. So delta x equal to x into, like this it becomes delta L by L plus delta B by B it will become. And finally delta x value you have to find out, because all the given data are present here. And answer finally what you get is, that is 0.05 after substitutions. So next, while writing this, x plus or minus delta x is equal to 3.17 plus or minus 0.05, like this, centimeter. So formulas, you should be very thorough with the formulas. Then easily you can do step by step like this. So this is all about the 20th question and its solutions. Given data L and B. Next, you have to find out what is L plus B. Yes, we got direct adding. Remaining, we cannot simply just add the errors. We have to substitute and we have to find out what is delta x values. So that is about question number 20th. So let us continue the next question. Next question is 21st question, and the question is, the radius of the sphere is measured as, so radius is given of a sphere, okay. So radius is equal to 5.2 plus or minus 0.2 centimeter is the radius. Then the percentage error in the volume of the ball, that means delta V is equal to how much percent, in the sense delta V by V. Relative means, okay, relative error after that in percentage if you want means percentage error. Delta V by V is equal to how much percent? This is what the question. Now we know volume of a ball means, what is that? Is equal to 4 by 3 pi r cube. Correct. So here what we are supposed to do? What is that? R is given there. So delta R by R is how much? Delta R by R means this is 0.2 divided by 5.2, correct? Next, what is required? Delta V by V is equal to, how much is that? It is 3 into delta R by R. So delta V is equal to what? Or delta by V is equal to 3 into, how much is that? 0.2 divided by 5.2. So when you multiply this, you have to get the answer somewhere around that is 0.115. So when you want to write that in percentage, so delta V by V into 100 is equal to 11.5% is the answer. So 11.5 is the answer, means what is the nearby answer there? That is approximately 11%. Okay, that is 21st question.